thing from router 1 to router 2. The router
Okay.
2 didn't respond back. I mean, if you
Yes.
send hello message, the router 2 didn't respond back. That's down, right?
Okay.
So and when you send hello message, and they just only play you on hello message. That's it.
Yes. Without
That's end.
neighbor router ID.
Yeah.
Okay. Then
And two ways when you send hello message, they reply hello message and they send you the with include router ID as well.
okay. Very good.
Right? And X start when you send hello message and they send like a router ID and you receive router ID, and also they they send the third message for, I think they send the third message.
Yeah. Third message. Two-way
Yeah.
state. In two-way
No, that's
state.
yeah. That was two extent like it stopped till that much when they send a router ID and they receive router ID, and I think that then they sent acknowledge or what message? What do we call? I think
Okay.
I'm,
Okay. Let me make you understand with one diagram here. Oh, I have not shared my screen now. Through this diagram, try to explain. Pen. Huh. Now, hope my screen is visible.
yes, it's visible.
Is this picture visible?
Yes.
See, I have again two router 1 and router 2. Router 1 have router ID what? 1.1.1. Router 2 have router ID 2.2.2. We had already discussed router ID as well.
Yes.
Router ID is identification of a router
Router.
in OSPF. We have two methods to configure router ID on router. One is manual and one is dynamic. Let's say router 1 have router ID 1.1.1, router 2 have router ID 2.2.2. Okay. See, first down state. Okay, down state is clear that whenever router 1 will send hello message, but if it will not receive the hello message, that so state of that interface will consider as down.
Mhm.
After that, in each state you can see router are sending as well as receiving the hello message. But in this hello message, in any state, router sending hello message, but in that hello message, hello message, that hello message carry only the router ID of
Router one.
sending router.
Mhm.
In two-way state, router is sending or receiving hello message with their own router ID as well and their neighbor router ID as well. Am I right?
Yes.
Okay, both routers are sending the hello message with their neighbor
Router ID.
router ID and their own router ID as well. So a state will be two-way state. Down, only router is sending hello message, but it is not receiving the hello message. In it means it is sending hello message as well as you can see seen hello message on the particular interface. It have received the hello message, but in that hello message, uh, router neighbor ID is null. Neighbor router ID is null. In two-way state, neighbor router ID is also there. After that, in two-way state, DR and BDR election will happen. DR and BR if needed. Okay, so we will see concept of DR and BDR later. Okay, but these things keep in mind. You need to keep in mind this thing that DR and BDR election is required in two-way state only. After that, we have access start state. In access start state, router send DBD message, and that DBD message contain LSA header only. Both router will send DBD message, and the DBD message will carry LSA header. After that, exchange state. In exchange state, again routers are going to send DBD message with LSA header. And in loading state, it will share LSR, LSU, LSAC, link state, request, acknowledgement, and update. So actual network information will be exchanged between the router in which state? In loading state. And after exchanging the LSAs, routers are going to form full way neighborship. So this we already discussed in last class. Am I right? Am I right, guys? Is it
Yes,
clear?
you are right.
Yes.
So if anyone need a screenshot, or let me share this picture with you. This picture with you. This picture. OSPF estates. Now, see, I have one topology like this. I have one switch here, and I have some router. Let's say this is my topology. In this topology, understand what is the problem. Let's say this is my R1, R2, R3, and R4. Guys, this is switch. In this topology, tell me how many neighbor are there of router 1? How many neighbor of R1? There are 3 neighbor of R1. Router 4 is also neighbor. Router 2 is also neighbor. And router 3 is also neighbor. Yes or no?
Yes.
In the same way, router 2 have also 3 number of neighbor. In the same way, router 4, router 2, router 3, and router 1, all routers have 3 neighbor. So total number of neighborship, if I will discuss about the total number of neighborship over here, so total number of neighborship is n into n minus 1 divided by 2. N is number of router. So number of router is here 4. 4 divided by 4 multiply by 4 minus 1 divided by 2. What value you will get here?
8. Not 8.
Not divided by 2. This is the only formula. So how many neighbor are there? How many? N is router. N is router. So number of router is 4. So 4
8.
multiply by 4 minus 1. It will be 8, not 8. 4 multiply by 3. 12.
You say over there like minus 2. That's why.
Yeah, minus 2. Minus 1. Oh,
It's
it is
12.
minus 1. 12. That means total number of adjacency is 12 here. Total number of neighborship is 12. Getting my
How?
point? See how? Router 1 have 3 neighbor.
Yes.
Router 2 have also 3 neighbor. So 3 plus
Oh,
3 is 6. Okay. So let's say if I have 10 number of routers in a broadcast network, because these all routers are connected with one switch. So this is one broadcast domain. So in a broadcast domain, if there are 10 number of routers, so number of adjacency will be 10 multiply by 10 minus 1. It will be what? 90. Yes or no? Oh my god. So if there are 90 number of adjacency, or let's say 12 number of adjacency in this topology, so router 1 will share their database to all neighbor, then that router will share their database to their all neighbor. Let's say router 1 have some network and router 1 have sent that network information to router 4. Now it is responsibility of router 2, router 4 to share to their neighbor as well. Yes or no? So it will share same network information to router 2 and router 3 also. And router 1 will also share same information to these neighbor, because all are their neighbor. Yes or no? Then when router 2 will receive any network information from router number 1, same network information will be flooded by router 2 to router 4 and router 3 to their neighbor. So in this type of network, number of flooding is very high, number of adjacency is very high. Let's understand with one real time example. Let's say this is one classroom. In this classroom there are 40 students. This is classroom. This is the door of your classroom. Let's say from here teachers are coming or students are coming in the classroom. Here is the chair of teacher. Let's say this is chair of teacher. Here teacher are seated, and then he is teaching to the student. How many students are there? 40, or let's say 100 students are there. So now guys, just assume that if someone is coming in the class, and he is asking for the day, which day is today, or someone is coming in the class and he is asking for the day of the first exam, anything. If someone is coming in the class and they are asking for anything, and if these all 100 people will reply to that people, then definitely in the classroom cloud will occur. Yes or no? There will be cloud. Am I right?
Yes.
Crowd will be there because there will be lots of sound. That person will get confused that what people are saying. So that's why out of these 100 people, how we reduce this flooding? We reduce this flooding with the help of monitor. We will select one student as monitor in the class. Yes or no? One student in the class should be monitor. What is the use of monitor, guys? That whenever someone will come in class and they will ask something, or teacher will ask something, only monitor will reply them. And whatever a student, if a student need to tell something to principal, so a student will tell to monitor and then monitor will tell to principal. Yes or no?
Yes.
Getting my point? Guys, no problem if you are not getting my point. Please tell me. I will explain another example. I will give you, another example. I have lots of example. Is it clear that why we are selecting one student as monitor to reduce the flooding? That whenever someone will ask anything in the class, all people should not speak. All people will share their query to monitor, and monitor will pass that query to the principal. Getting my point? Yes or no? What is the benefit? Benefit is we reduce the flooding. Am I right?
Yes.
In the same way, in this network, if every routers are sharing their database with each other, so there is flooding. We need to reduce this flooding. So that's why we will elect one router as monitor router, and that monitor router is nothing called DR. DR stands for designated router. Designated router. Getting my point? And in the class, like monitor, there should be one more monitor, that if monitor will absent, then what will happen? So that's why we should have one backup of monitor as well, sub monitor. So in the same way, in this type of network, we will have one designated router and one BDR, DR and BDR, backup designated router. That whenever my designated router will goes down, then backup designated router will become backup designated router will become backup designated router will become designated router. Getting my point? Now question is, in this network, which router will become DR? So DR is clear to everyone. That DR is a special types of router in broadcast network, right? And all other router will share their database with DR router, and only DR routers are going to exchange the database. Let's say first of all make you understand how this will work. Then we will discuss which router will become DR. Okay, on the basis of what a router will become DR. Let's say in this topology router 4 is my DR router. Router 4 is DR router. Router 1 is DR other. All other router will become DR other. DR other. DR other. DR other. DR other. And concept is DR other router will form full way adjacency only with DR router. It will not form full way neighborship between DR other and DR other. DR other and DR other, there will be two-way neighborship only. Two-way neighborship only. Two-way. DR other and DR other cannot form full way neighborship. So here also neighborship will be till two-way only. Two-way. Between router 1 and router 2, router 3 also neighborship will be till two-way. Two-way. And all DR other will form full adjacency with DR router. So there will be full adjacency here. Full adjacency will be there. Between router 4 and router 3 also there will be full neighborship adjacency. Full. Between router 4 and router 2 also there will be full adjacency. So now tell me how many adjacency are there? How many full adjacency are there, guys? Only three. So we have reduced the number of adjacency. We have reduced the number of full neighborship. Yes or no?
Yes.
And now let's say router 2 have one network 10.1.1.0/24. So router 2 will share this network information to router 2 will share this network information to DR router, means to router 1, and now it is responsibility of DR router to share this network information to other router. So it will share to router 1 and router 3. Now you can see everything is going in very symmetric form. Yes or no?
Yes.
Router 1 cannot share their database directly to router 2 or to router 3. How router 3 will get database of router 1? Through DR router. Router 1 will share to DR router and DR router will share to router 3. Done. So is it clear?
Yes.
Why we need DR and
Yes.
BDR? To reduce the flooding in broadcast network.
Do we have BDR in this topology?
Yes, one router will have BDR also, but here I have not designed BDR.
Okay.
Okay, so BDR is nothing but the backup of DR.
Okay.
Okay, so one router will be BDR. We will discuss later. Don't worry. Now is it clear, guys?
Yes.
Now question is which router will become DR router. So router who will have highest priority will become DR. What I am saying, router who will have highest priority will become DR router, and by default priority on all router is 1. So by default all routers have what priority? 1. So can you tell me which router will become DR? No. So now if priority will tie, then it is going to check. This is the first way, first option. Second option is, if priority will tie, then router who will have highest router ID will become DR. And as you know, router ID is identification of router. Two router cannot have same router ID. Getting my point?
Yes.
So by default priority on all router is same, and router ID of router 1 is 1.1.1, router ID of router 2 is, let's say, 2.2.2.2, router ID of router 3 is, let's say, 3.3.3, and router ID of router 4 is 4.4.4. So you tell me which router will become DR?
Router 4.
Router 4. And if you want that a particular router should never become DR, then you can configure priority 0. If a router have priority 0 will, if a router have priority 0 will never participate in DR or BDR election. If a router have priority 0, that router will not participate in DR and BDR election. Getting my point? So if you want that router 2 should never become DR or router 4 should never become DR, then we will configure priority 0 there. Okay? Now let me make you understand same thing with this, with one topology. Practically it will definitely clear your all concept. Just wait. It will happen only in network whenever network type is broadcast. In the broadcast network, only DR and BDR election is required. Because let's say I am connecting two router together, 1 and 2. Do you think that DR and BDR is required here, guys? Here DR and BDR is not required because total number of adjacency is only 1. Here I cannot reduce the number of adjacency. Yes or no? So in this type of network, DR and BDR is not required. Yes or no?
Yes.
Yes or no? In this type of network, DR and BDR is not required because router 1 is directly connected to router 2. This is point-to-point connection. So here DR and BDR is not required. We will configure priority 0 on both router.
Okay, if there is a 3 routers, then
If I
there
have
is
3 routers like this, router 1, router 2 and router 3, then also DR and BDR required is, DR and BDR is not required, brother. Why DR and BDR is not required here? Because we will have one neighborship here and one neighborship here. Can I reduce the number of adjacency here? No. Whenever more than 2 routers are connected on same segment, then only DR and BDR is required. In this topology, you can see 4 routers are connected on same segment. Getting my point?
Yes.
Here DR and BDR is not required because between router 1 and router 2 point-to-point connection, between router 2 and router 3 there is point-to-point connection. Okay? So DR and BDR is not required there. Okay, now I am going to design one topology here. Let's say router 1, router 2, router 3 and router 4. Let me take one switch and I am going to connect these all router through switch.
And DR reduce the number of what? You say
Reduce the number of adjacency, or you can say reduce the flooding, LSA flooding.
okay.
If you want to see these things, you can directly search on Google why DR or BDR in OSPF. See the result. In OSPF broadcast network, OSPF elect one router to serve as designated router DR, another router as BDR, backup designated router. Why? To minimize the amount of repetitive information that is forwarded on the network. Repetition of information. As I told you that in this topology, if all routers will form neighborship, then router 1 will share same network information. Router 1 will share their database to router 2, to router 4, to router 3. And these router will also flood same information to their neighbor. So there is repetition of data, yes or no?
Yes.
Getting my point? So there is only difference of language, otherwise concept is same. Okay? Now let me turn on this device. And I am going to configure router ID on all routers with router name. Like on router number 1, router ID will be 1.1.1. On router number 2, router ID will be 2.2.2. On router number 3, router ID will be 3.3.3.3. And on router number 4, router ID will be 4.4.4.4. Okay, let me configure and see in this segment I need to use one network. So let's say I am using here network 192.168.10.0/24. This is the network of this segment. Okay, or I can say IP address of router 1 is, let's say, 10.1. This is the IP address of router 1. 10.2 is the router ID of router 2.
So here we only use one network ID for the whole routers?
Yes, because see now all routers are connected with same segment. Switches don't separate network, yes or no?
Yes.
switch cannot separate the network.
Got it.
Okay, now on router number 1 I am going to configure the IP first. Interface F0/0, no shutdown, and IP address is 192.168.10.1 exit router OSPF 1. Router ID 1.1.1.1. App configure router ID 1.1.1 on router number 1. Let me take to router 2. Interface F0/0, no shut, and IP address is 192.168.10.2. Router OSPF 1 and router ID is 2.2.2.2. In OSPF I am just configuring the router ID now, nothing else. On router number 3, I have not enabled OSPF on interface. Router ID 4.4.4.4. Now see one more concept. Whenever we will configure, we will enable OSPF on the interface. Let's say when I will enable OSPF on fast Ethernet 0/0, router 1 will wait for DR and BDR election for 40 seconds only. It will wait for 40 seconds only. Within 40 seconds, if router 1 will receive any hello message with their neighbor with higher priority, then only router 1 will declare their self that router 1 is not DR. But within 40 seconds, if router 1 will not receive any hello message from router number 1, it will declare their self as DR. Okay? So let's say between me and you, there is one election. There is one election that who is winner. And for election, just we need to wait for 40 seconds. So for 40 seconds, we will fight. And if I will not fight with you for 40 seconds, then after 40 seconds, you will be winner. Yes or no? After 40 seconds, you will be winner. Like that, it will work. 1 second, guys. It's like if you are learning these things for the first time, then you should read book as well, right? You should read article on Google about OSPF. Okay, so let me do one thing. Here I am going to enable now OSPF. So first of all, let me write the command in notepad so that I can put command on all router within 40 seconds. What command I need to run? Router OSPF process 1 and network 192.168.10.0, and area 0. I need to run this command on all routers. Let me copy the command. First of all, I am going to paste this command on router number 1. Then I am going to paste this command on router number 2. Then I am going to paste this command on router number 3. Then to router number 4. So I have configured OSPF on all routers within 40 seconds. So one router is going to become what? DR. And if you see by default priority, as I told you, by default priority is 1. So IP OSPF interface brief. What is process ID is this one, and here we are not able to see the priority. Am I right? Here we are not able to see priority, only area, cost, and state is waiting. Okay. So IP OSPF interface fast Ethernet 0/0. What is priority by default?
1.
By default priority is 1. And for DR and BDR election, you can see state is now what?
Waiting.
Waiting, because it will wait for 40 seconds. And if you will run this command now, so IP OSPF interface fast Ethernet 0/0, now you can see this router is
DR.
DR other.
DR other.
DR other. Then which router is DR? So we
Router
can check. So IP OSPF neighbor. So IP OSPF neighbor. Which router is DR router? Which router is DR?
Router 4.
Router 4. Why? Because priority is same and router 4 have highest router ID. So router 4 have become what? DR. And then which router have the second highest router ID? Router 3. So router 3 have become what? BDR.
Buffer.
And you can see router 1 have full adjacency with DR router and BDR router only. DR and BDR. With DR other, router 2 is DR other. So DR other and DR other, neighborship is still two-way state. Getting my point?
So we're supposed to do configuration before 40 second.
Yes, before 40 seconds you need to configure OSPF on all routers.
If you can do that, then what happened?
If you will configure, let's say I am going to remove the OSPF configuration from router number 1 from all routers. Say no. Okay, let me run this command here. I'm going to remove this no network command here. Say no. Okay, copy the command and let me paste this command on all router. It will remove OSPF configuration from fast Ethernet 0/0. Router 2 also, router 3 also, and router 4 also. I've removed OSPF configuration from all routers. Now again you can see do so IP OSPF neighbor. We don't have any neighbor. And so IP do so IP OSPF interface brief. I don't have any interface enabled OSPF. Now I am going to run router OSPF 1 and network 192.168.10.0 0.0.255 area 0. I have enabled OSPF on router number 1 fast Ethernet 0/0.
Yes.
And I am waiting for 40 seconds. So after 40 seconds, this router will declare their self as DR. Because this time it is not router 1 is not going to receive any hello message with higher router ID. Getting my point? So
Yeah.
IP OSPF interface fast Ethernet 0/0. You can see now it is waiting.
So
Now
because
it is
because it didn't
yes.
receive, we didn't enable OSPF and other routers.
So we have not enabled OSPF on any other router, right? So this router is waiting that if any router have higher router ID, then that router will become DR. I will not become DR. But it have not received any hello message with higher router ID. So this router is declared that I am DR. And
So
once one router will become DR router, after that, if you are configuring router number 4 with higher router ID, DR is not going to change, guys.
so the DR should be then the DR should
DR.
be router 1.
Yes, then DR router 1 should be the DR. Once Prime Minister election will done, right? Doesn't matter other people have more power, that person cannot become Prime Minister. Yes or no?
Yeah. Is there any difference, like if the router ID is lower than router 4 and the router 1 is DR? Any difference or no? Same happen?
Yes, can you repeat?
Yeah. My question is, okay, now we configure OSPF and other router after 40 seconds, like we did slowly, right? Now
Yes.
router 1 is DR, right?
Hmm.
So like before it was router 4. So what's the difference between router 1 and
No,
router
there
4?
is no difference. This is, the behavior that
Okay.
interviewer can ask you that this is my topology. In this topology, which router will become DR, let's say.
Then both were the same way, right? If it's
Yes.
DR4 or router 1 is the same way, right?
Yes.
Good,
So
okay.
you know already that router who will have highest router ID will become DR router. But the election time is only 40 seconds.
Got it. Okay.
Okay. So again, I am going to enable OSPF on all routers. On router number 2 also, I'm going to say router OSPF 1 and network 192.168.10.0.0.255 area 0. Let me copy the command so that I can paste this command on other router as well. Let me paste the command on router number 3, router OSPF 1, and paste. On router number 4, router OSPF 1, and paste the command. Done. Now here router 4 is going to become what? BDR, not DR, because DR election is already happened in this topology.
But I have a quick question.
Yes,
Why did you use the same network ID to all of the routers?
because we are using same network, brother. Here this is broadcast network, multi access. Through this segment multiple routers are connected.
But it's not same. The one is the last one is 4321.
Last bits is different. Network ID is same na. Means network is same. Network ID is same of all network. Network ID is what? 192.168.10.0. Network ID of all routers is this one.
Oh, okay, got it. Got it.
Okay. So now in my scenario, if you will check on any router, so IP OSPF neighbor. Who is my DR? Router 1 is DR, router 2 is DR other, router 3 is DR other, router 4 is DR other, router 2 is BDR. Router 1 is DR now, router 2 is BDR now, and router 3 and router 4 is DR other. Which router should be DR? This can be your question. So guys, as you know, DR have some more load. DR router have some more load. So the configuration, hardware configuration of DR router should be good. So out of these 4 routers, one router, let's say you have one good router. Router 4 have the good hardware. So your router 4 should be DR. And you know how we will implement this in real time. Let's say router 4 should be my DR, but now router 4 is DR other. Now router 4 is DR other. So I want what? Router 1 should always DR other. So here I will set priority 0. If I will set priority 0 over here, now you can see this router is DR. So IP OSPF interface include a state. This router is DR, yes or no? But if I will set priority 0 on this router interface F0/0, IP OSPF priority. This is the command to set priority 0. If I will set priority 0, then this router will never become DR. This router will never become DR. Now you can see here I have set priority 0. And now I am going to check. So IP OSPF interface fast Ethernet 0/0. You can see this router is DR other, because priority of this interface is 0. So now,
Okay,
so IP, yes.
at the beginning you did the same command. The router 4 was the DR, but the second time it's come to the number router 2. Like what's happened with it?
Router 1, second time router 1 is DR, because
Yes.
I have configured OSPF on router 1, then I have wait for 40 seconds. Within 40 seconds, if you will configure OSPF on all routers, then only router 4 will become DR. Guys, DR BDR election time is 40 seconds. Okay, so whenever we are configuring OSPF, router will wait only for 40 seconds for the DR and BDR. If router will receive hello message with higher priority or higher router ID, then only router will not declare their self as DR.
Okay, this time would be in the real device as well.
Yes,
Oh,
Do you want to see it on real device?
yes, for
I
sure.
will show you it on real device as well. I will configure
Okay, thank you.
same topology I will design in my rack also.
Thank you.
Here is my rack in front of me. Let me take one picture and let me share with you.
Okay.
Here is the rack, see. And let me share it in group. This is my rack, brother. In my rack, you can see there are upper 4 devices router and lower devices are switches. Okay.
Yes.
So I can design same topology in rack, in this rack, and then also I can configure OSPF. So for now, so IP, OSPF, neighbor. So you can see now router 2 is what?
Full DR.
DR. Because earlier router 2 was BDR. So whenever DR will goes down, which router will become DR? BDR. BDR will become DR. Note the router who have highest router ID. Router who have highest router ID will become what? BDR. Router 4 have become BDR. And again, if I will run what? Priority 0 on router number 2, then what will happen? Router 2 will not become DR. So router 4 will become DR and router 3 will become BDR. So let me show you that also. On router number 2, I am going to say interface F0/0 IP OSPF priority 0. Here also I have set priority 0. And now you can see on router number 1, so IP OSPF neighbor. Which router is DR now? Router 4. And which router is BDR now? 3.3.3. And I don't want BDR in my topology. So on router number 3 also I can set priority 0. On router number 3, go to interface F0/0 and say IP OSPF priority 0. Now if you will check on router number 1, you can see only router 4 is DR. There is no BDR now. Now there is no BDR. And all routers will form full adjacency with DR router only. Between BDR and BDR, neighborship will be till two-way state. So in two-way state, DR and BDR election will happen. Okay, guys? Is it clear?
Yes.
Is it clear?
Yes.
Yes. Hey guys,
Yes, yes.
we have to buy like 4 routers with all required materials. We will do this one topology.
Yes, to design a rack,
Yeah.
you need to buy 4 routers
Mm.
and 4 switches. With the help of 4 routers and 4 switches, we can design any topology. Like Sina, I want to design this topology. I have 1 switch and I have 4 router in rack. I can connect all router through a signal switch.
Okay. I will talk with these 2 guys, and if they agree, we have to buy. Like if we learn the practical, that will help us more.
That's expensive, bro.
Yeah.
But yeah,
this-
but I have one switch. I can rent it to you.
And the switches for whom it doesn't work.
You know, it will cost you around, let me show you. Let me tell you
It is expensive.
how much. No, it is not expensive, brother.
No, if you want to learn something, we have to.
You need to purchase the old devices. Only $600.
Yeah, $600. We can return it back.
Oh. How return it back?
We'll buy from Amazon, and then when we're done our work, then we return them back.
No, bro, they
You
don't have
can
return policy for electronic devices. It's
you
like
can buy it on eBay.
PM. Can
CCNA
you send us the brand,
rack.
the good brand for? I mean, not expensive. I know
It's in the rack rental, yeah.
Cisco is expensive, but
In US na?
Yeah.
we need a manageable, right?
Yes.
Manage, yeah, manage. It should be manageable. It's more expensive.
Here it is. Okay, here we have less device.
It's very important for us.
You know, now guys, you don't need rack really, because you can perform practical in GNS3 or even G. Later on, after learning CCNA and CCNP, you can purchase it. For now, don't purchase it.
And then we also need Windows Server.
No, Windows Server is not required here.
Okay.
Okay, one thing I will request to the Green River if they help us. College.
Yeah, we can say we are a team.
Yeah.
We are three students. We are a team. We need this
Now, what is
device.
next in OSPF? DR and BDR is clear to everyone? Hope
Uh,
it clear.
Yes.
I'm still a little bit confused in gear and media.
There is nothing, brother. Don't confuse yourself.
If it's explained the short, like it's a conclusion.
Just keep in one thing. I'm telling you guys very honestly that whatever things you need to keep in mind in this concept. DR, BDR, first of all, in which states of OSPF neighborship DR, BDR election will happen? In two-way state. Okay, this is important. In two-way state, one routers will become DR and other routers will become BTR. But if I will connect two router together, let me connect two router. Here one router, two router. I'm going to connect these two router through serial link, because this is point-to-point connection. And if I will configure OSPF in this network, let's say between these two routers I am going to use network. Any network, you tell me which network you want to use here between router 5 and router 6. Let's say 56.1.1.0/24. Done. Let me configure the IP and OSPF. Router 5, router 6. Config T, interface serial 2/0, no cert. IP address 56.1.1.5, 255.255.255.0. Router OSPF 1, router ID 5.5.5.5. Exit interface serial 2/0, IP OSPF 1 area 0. This is the command to enable OSPF. This should be clear to everyone, right? We have two options to enable OSPF on interface, one through network command and one through this command. So last time you told me that this is EG, so that's why I am using this command. Okay, otherwise like EIGRP I can use network command also. On router number 6 also, let me configure the IP address on serial 2/0, no cert, and IP address 56.1.1.6, 255.255.255.0, IP OSPF 1 area 0, and router OSPF1 router ID 6.6.6.6. Done. So IP OSPF neighbor. See, there is no DR and BDR. Yes or no?
Yes.
Because here DR and BDR is not required as well. Getting my point? So second thing is, first thing is DR BDR election happened in two-way state. Second thing is DR or BDR is required in broadcast network. This is the second thing that you need to keep in mind in OSPF. First thing, the state. Second thing, that when DR and VDR is required. Third thing is router with highest, highest priority will be DR. Fourth thing is, if priority is same, then high router with highest router ID will be DR. Only these four things here you need to understand, you need to learn. How easy it is, yes or no?
Yes.
Nothing else. So is these four things is clear?
Yeah.
Tell me honestly, guys.
Yes, the only one, number one, two-way. So
Two-way.
and those two network we also have the two-way connection, right?
No, in two-way state DR and VDR, here you can see OSPF states. What I am saying, that in two-way state DR and BDR election is going to happen. In
Okay.
two-way state DR and BDR election is going to happen. That's it.
Okay.
Okay. Fine.
Yes.
I think that's clear now.
Hmm?
That's clear now.
What next in OSPF?
Next will be done for today.
Okay. Now I'm going to delete this topology. And I am going to design one very simple topology here. Router 1, router 2, router 3, router 4. OSPF work on the basis of area concept. On the basis of area concept. Or I think I have this topology. Let me check. GNS3 task. Here OSPF area. Yes. Wait, it will take some time to open. No, no. This is different topology. I'm not talking about this topology. OSPF DR, OSPF over DM VPN, OSPF prefix. No. Where is the topology which I am looking for? I think that topology is in, EVNG. How much time we have now?
I think we don't have time.
Oh,
Guess what, Soha? Do you have time, Soha?
What? You're the best, man.
Soha, do we have time?
Uh,
I don't think so. I know.
Kanda was sleeping.
No,
Okay.
Oh, bro.
of course, because Soha sleep early. That's why I say for Soha.
there are some more concept in OSPF that I will continue tomorrow.
All right.
The
Yeah,
only
that's
question
good.
I have about area,
Okay.
like how
Ask
you
your
can.
question tomorrow, bro.
Okay, just short question.
No, I'm kidding. I'm kidding.
Yeah.
Okay.
You know
Yeah,
how?
area concept we are going to cover tomorrow as well.
Okay,
Yes,
good.
yes, tell me.
Okay, good. Okay.
Tell me, by the way.
No, the only question was about area. How we know like which is area 0, which is area 1 or 2?
Yeah, that will be, we will cover tomorrow, definitely.
Okay.
That's
OSPF
good.
work on the basis of area concept. Okay.
Yeah.
Till now we have discussed the basic configuration of OSPF, OSPF states, DR, BDR election. Okay. These things only.
Okay.
There are some more concept as well.
Got it. Okay.
Okay, guys.
Yes.